Hello and welcome to SystemVerilog in 5 minutes. Today we'll talk about assertion and property. This is a simple number generator. Now say if you want to check the numbers whether they are even or not, the most primitive way is to use an if-else statement. It passes if the condition is met, else it prints an error. Actually, the simpler way to do this is to use the syntax assert. This is the same as the if-else statement. It automatically prints an error if the condition is not met. If you don't like the default error message, you can write your own else statement, but remember to remove the semicolon here. This is known as immediate assertion. Basically, the assertion is put at the point where you want to perform the check. If we look at the waveform, on every positive clock edge, the value is changed. Then the assertion is performed. So the assertion is checking the value after the clock edge. As for the passing and failing numbers, 1 and 3 would fail, whereas 2 and 0 would pass. The first 0 here is not being checked. The problem with immediate assertion is, first, you may not have the permission to modify the file to put the assertion where you want it. And second, it's harder to write a check that spans across multiple cycles with immediate assertion. But we'll only discuss about that in future video. If we write an assertion separately, the timing can be confusing. For the toAlways block here, the value can be changed first, followed by the assertion. So the assertion checks the value after the clock. Or the assertion is performed first, followed by the change of value, in which the assertion checks the value before the clock. Now there are ways to avoid this confusion. We can use neckage with the assertion. This puts the check right at the middle of the value. Or we can use deferred assertion by using #0. This puts the assertion to be executed later than the assignment here. This is not good because we are assuming the assignment would not have any delay mechanism, but generally it can, and worse, it can have multiple changes of values. In that case, we can use assert final, which checks the final value and not the glitches. Now another way of writing assertion is concurrent assertion. We use property to define a behavior. This is a property, this is the name, this is the event trigger, and this is the expected behavior. The property is just a definition, we need to instantiate it. This is a label and it is optional, but it is recommended to have one. It is similar to giving name to this instance. As of timing, assertion is performed on sampled value from preponed region. Practically, it always checks the value prior to the event trigger. This is generally a more complete property. It has a disable if statement, which disables the assertion if the condition is met. The double F here is correct. Note that these 3 lines are actually one statement. There is no semicolon here and here. The bracket here can contain prod, which makes a property reusable. Here the property is hard-coded for this variable b, but here the property has an input port b. So you can use this property on any variable, like x and y here. Property can also be used with other syntax such as cover. Assert property will fail if the condition is not met. Cover property is to sample if the condition has happened. In one way, it's similar to cover point, but that's not our focus today. The disable if statement has a confusing behavior. The disabling condition is evaluated at observed region, but the behavior evaluation is at preponed region. If the disabling signal is asynchronous to the clock, it is easier to understand. In this duration, when the condition is met, the assertion triggered by these 2 clocks are disabled. Therefore, these 2 values are not checked. But if the disable signal is synchronous to the clock, it's a bit of a puzzler. Every time the event is triggered, the assertion looks for 2 things. One is the value to be checked, which is the value before the event. And the other is the disabling condition, which is evaluated after the event. In this example, the checked here is disabled, while the check here is enabled. The value which is totally within the disabling duration is checked. Now if you don't want this behavior, you can write your assertion in this manner. But again, this is where the source of confusion comes from. At this clock, the assertion is enabled because the disabling signal is evaluated to be 0. But the behavior evaluation here sees the sampled value of disable signal as 1, and therefore the expression this equals 1 is true. If you are totally confused, you may choose not to use the disable statement and code the disable condition in the behavioral evaluation here. Well, that's all for today. In the next video, we'll continue on some examples on concurrent assertion.